Welcome to the session, everyone. So today we'll be talking about the benefits of data science. So first, before we talk about the actual benefits, the question is, what exactly is data science? And here's a definition from Wikipedia. Data science uses scientific methods, processes, and algorithms to extract knowledge and insights from structured, noisy, or unstructured data. It is related to data mining, machine learning, and big data, but we need to keep in mind that it's not only all those things. Data science starts with smaller goals, like normal data analytics is also part of data science. Stratification, Benford's law analysis, things that we normally do as auditors, all of these are also part of data science. But most importantly, something that we need to keep in mind, what exactly is when we talk about data science, and this is the way I see things, this is the way I was telling my teams when I was working with them. So what exactly is data science? It's very important to keep in mind that the purpose of information is not knowledge. This is what Peter Drucker, the guy here on the photo, one of the top management consultants of the 20th century, said. Data science information is being able to take the right action. And this is what data science is all about, giving us the insight and the ideas of what needs to be done in our organizations. What do we need to do in our work in order to improve the efficiency and the effectiveness of processes or the overall organization. So some things about data science. Data science is about business. That just follows from the previous slide. So it is not about technology. Just because it's got the word data doesn't mean that actually it is a technology initiative. Technology is just one of the tools, but we need to focus on business outcomes. In audit specifically, we need to link any data science or data analytics activities to the terms of reference for a specific review. Business outcomes for auditors are defined in the terms of reference for each review that we are doing. As I said, it is not a technical initiative. So just because we have the word data, it's not about technology. We cannot outsource data science or data analytics to technical people. Whether it's in audit, whether it's in the business side of things, technical people need to be there, but the drivers need to be the business people. In this case, because we talk about data science in audit, in this case, the drivers need to be the auditors. So do not go to the technical people in your organization and expect them to be able to give you some advice on these things because they don't know what you want to do. They can give you some ideas up to a point. However, after that, it is up to you to decide what exactly you need to do and why you need to do it. Technical people can give you a little bit of an idea about how to do things. It is also a cultural undertaking. What I've seen in my working life is that people do not accept new things very easily. So actually for an audit team to become really productive, what needs to happen is that everybody on the team needs to be convinced of the benefits of data science and to be involved in some shape or form with it. This needs to come from the top, from the chief audit executive, audit director, or whatever the name of the title is. But the person at the top needs to be able to actually start creating that culture. Unless people on the team see that people, the top managers, are involved, they are not going to follow. So just keep that in mind. You need to get, if you are a chief audit executive, you need to drive it. If you are not a chief audit executive, you need to get the support of the chief audit executive and actually start looking at data science and what it can do for your audits. Now, I'm saying it's a cultural undertaking and everybody needs to be on board with it because it is an activity, data science is an activity that 50 to 80% of auditors can do. It is not something extremely complex. It can be, and certainly only 5 to 10% of the auditors would be interested in dealing with big data or machine learning or artificial intelligence. However, simpler, not simple, but simpler analytics or simpler data science can be done by 50 to 80% of the team, which means that overall, most of the audits that the team will be doing will be vastly improved. That would mean saving time and, of course, saving money. If we can save half a man day on 20 audits, that means 10 man days a year. That means that actually we can, using the same budget, we can do an additional audit, or we'll have more time for ad hoc reviews, for example. So why do it? These are the 7 benefits that I was talking about before. So we want to increase the quality of our audits. Okay, here's William Edward Deming. By what he says, in God will we trust, all others bring data. Yes, I'm a big believer of gut feeling, of intuition, and so on and so on. On its own, they are all very valid. The intuition is very important, but we need to back intuition with data because quite often intuition can lie to us. It has happened to me. My guess would be that it has happened to all of you here in the room. So intuition is great, but we need to support it with data. So just saying that there is an issue in a specific process is one thing. Actually showing the hard data, because with the results from any data science activities that we perform, is a totally different thing. The credibility in the eyes of the audit committee, in the eyes of senior management, will be greatly improved. It will make us also more efficient, okay? Doing things manually is not an option, really. We are talking about large amounts of data that all of us have to deal with. We do a review, we review the payroll process, we review the sales process, we review some of the production processes. The reality is that we are talking about some huge data amounts. And doing things manually is not going to help in that respect. With data science, we can actually go and analyze or process whatever amount of data is thrown at us. So as a result, yes, I appreciate the fact that it takes a little bit of time initially to become proficient, to set up sometimes the data science initiatives. However, once that's done, we'll be much quicker in whatever we're doing. It will give us business improvement insights when we do data science. Okay, sorry. So here are a few examples. So Walmart is using data science to improve inventory management and to reduce out of stocks. Now, Walmart is a huge corporation. An equivalent to Walmart will be IKEA in a lot of countries, because Walmart is present mainly in America, but no matter which country you are coming from, very likely IKEA will be there. Same thing. Using data science, analyzing huge amounts of data, we can improve inventory management because we can see it on an individual item basis what is happening and actually remove out of stocks. Now, sorry. Data Alliance is using data science to better predict maintenance needs, and that has reduced unplanned downtime by 25%. Now, just imagine if you, as an auditor, during one of your reviews, identify that there can be an improvement in our maintenance activities, no matter what type of organization we are, and if we can suggest ways to improve that. Now, that would be awesome, because as auditors, now we are also becoming business partners and real consultants. We are not just focused on compliance anymore. We are focused on business improvement. for me personally as an auditor, that has always been extremely important. And in all of my audit reviews, whether I was doing them on my own or whether I was managing teams, I always was always focused on business improvement. Findings are findings. Problems with the process or certain activity are there. There's no question about it. However, business improvement is the key, in my opinion. This is the best value that we can deliver as auditors. And here's another example. UPS, the United Postal Service, is using data science to optimize package delivery network, which has saved millions of dollars. Yes, and I have done reviews actually where there was a GPS. There was GPS data as part of the review. Unfortunately, it was used for a slightly different purpose, where we have identified fraud using the GPS data, fraud on the parts of drivers and the teams that were with each driver. But nevertheless, in all cases, we can improve the organization and we can improve the way the organization performs using data science. So we can use data science also to develop productivity hypotheses. Benford's law is one of those. Benford's law basically says that there is a distribution that numbers in the first digit of each number in a large data set follows certain frequency distribution. What you see here is that digit number 1, which is the first bar on the chart, must appear or should appear about 30% of the time as the leading digit. Okay, so number 1 is around 30% of the time the leading digit. That means that in a set of invoices, let's say 500,000 invoices, the invoices that start with 1, for example, can be 1 million, can be 156 ringgit, can be $10,025, can be $159,000, doesn't matter. The amounts that start with 1 will be 30%. And then the amounts or the numbers that start with 2, second one is about 17%, going back to digit number 9. When 9 is the leading digit, only 5% of the dataset members will be like that. Now we can use that then to actually start developing hypotheses in terms of what types of potentially fraudulent activities are there. Here's an example. As you can see, the green line here is the predicted Benford's distribution. The actual blue bars are what happened in reality in a bank. And as you can see, number 4 appears a lot, 4 appears as a leading digit a lot more than it should be, while 5 appears as a leading digit a lot less than it should be. And turns out that in this specific bank, there was a process where loans up to $50,000 are approved locally at branch level. Loans above $50,000 are approved by the central office. So in several of the branches, what happened, the branch manager started actually suggesting to their friends that, listen, okay, you need $52,000. However, if you actually can drop the loan amount to 49 or 48, I can approve it here. You're guaranteed, almost guaranteed approval. It will happen within 3 days and it will be all good. If you cannot do that, then I need to send your loan application to the headquarters. There will be a committee of 3 people who need to approve it, and you will get back the result in about a couple of weeks. So with that type of proposition, a lot of people actually started dropping their loan requirements or loan amounts to a little bit below 50,000, so 48,000, 49,000, something like that. As a result, the loan applications starting with 4 went up, and the loan applications starting with 5 went down. Of course, if you need 59,000, it's not very easy to drop it to 49,000. So those amounts that start with 5, like 56, 57, 58, they still remain like that. But if you need a little bit over 50,000, why not drop it by $2,000 and actually get it on the spot? Now, it wasn't a fraudulent activity per se, and in other cases there has been, but not in this case, or maybe there was. But the thing is that the managers were trying to actually circumvent the company policies. So there was a consequence as a result of that. All of that was done because actually somebody applied data science and somebody applied data analytics in order to get the benefits. So somebody applied data science to get benefits analytics now. Overall, accuracy of audit reports is improved when we use data. So what happens if we start sampling? Okay, sampling, okay. It's got, I'm not a big fan of sampling. Some of you may have heard me talk about it. Definitely not. However, it does have its applications in very limited circumstances. But for most audit teams, the circumstances are not limited. Sampling is used all over the place. Personally, I disagree with that. And here is some statistics. Now, 0.05 to 0.1% of the invoices are double payments. In a company with $100 million turnover over 3 years, those double payments, whether they are fraudulent or whether they are by mistake, we're not talking here about that, will result in a $300,000 loss. Now, think about it. If we have 500,000 invoices, just as an example, and we sample, out of 500,000 invoices, only 250 to 500 invoices are actually duplicates. As you can see, 0.05 to 0.1%. Out of 500,000, we have 250 to 500 invoices which are duplicate, paid double. Now, what is the chance of you actually going to get that, one of those, or all of them, if you sample 300 invoices out of the whole day, or even if you sample 500 invoices? So you sample 500 invoices out of 500,000, and you are going to get all of the duplicates. I think that that's close to impossible. There is a possibility. The probability is very, very close to zero. However, when we use data science, when we run the whatever analyses we have over the full data set, can be not 500,000, can be 20 million invoices, it doesn't matter. When that happens, whatever we say in our report, they are not duplicates, or they are duplicate payments of X amount of dollars or whatever, we are pretty close to 100% certainty that that's the case. So overall accuracy is going through the roof, simply because when I sample, I may or may not get some of the problematic invoices. When I'm running everything across the whole data set, I'm gonna catch everything. Now, I know there is science and there is a theory behind sampling. I'm aware of that. However, when we start talking about sampling, I would like each one of you to think about the fact, or to imagine the situation. You are sitting in a plane which is just about to take off at the airport. So you're flying from KL or from Dubai International somewhere, and suddenly the person next to you turns to you and says, listen, do you know what? I work for Boeing, and you're sitting in a Boeing. I work for Boeing, and in our production process, we produce every batch of 100 planes is tested by sampling. We produce 100 planes. After that, we pick 3 of them or 5 of them, because the science says that when you pick 5% of the records, you're pretty close to covering the whole thing. So we produce 100 planes, we pick 5, we test them, absolutely. And then based on the results of those 5 planes, we write a conclusion, we derive a conclusion that the whole batch is okay to fly. And by the way, this is one of those planes that we're sitting in that we have tested by sampling. How would you feel? I don't know about you, I will be running for the exit. I don't want my plane to be tested by sampling. I want my plane to be tested like any others of the 100 planes in the batch. This is the same here. When we apply sampling, we are allowing a certain error, which can be quite high. When we actually use data science and we analyze absolutely every single record, whether it's an invoice, whether it's a customer transaction, whether it's a loan application, doesn't matter. We actually bring the number of errors close to zero. So this is how we improve the accuracy. Okay, we also can communicate better using data science, because visualization and data presentation is also part of data science. So, for example, here we have some data. This is, by the way, from a real audit report from the Indonesian National Audit Office, BPKP. Now, basically what the report says, that the audit office is they've done an audit of various provinces of the provincial audit offices, and they conclude that everybody is doing a great job. However, would you be convinced of that? Because that type of numbers just don't make any sense to me. I need to read a lot, and by the way, by the time I understood them when I was first looking at the article, I spent a few hours actually trying to work out what's what. But if we actually use a different approach of the storytelling, okay, we can say, all right, in 2015, going from the top left down, 31.1 trillion Indonesian rupees were lost due to corruption in 2015. Now, for the period 2012 to 2015, BPKP reported on issued 128 reports in various provinces of Indonesia and various provincial governments. There were 1.29 fraud cases in each provincial government from 2012 to 2015, with ranging from 0 to 4.5, but on average 1.9. The average audit opinion was 3.87. Maximum is 4. You can see the scale at the bottom. So 3.87. So pretty high, pretty close to 4, to unqualified. The irregularities, there were irregularities, looking at the fifth, the darker line is irregularities, the lighter line is the corruption cases. And as a result of all that work, 128 reports, 1.29 fraud cases, we discovered as many as whatever, 3.8 average audit opinion. We can conclude that PPKP, Indonesian National Audit Office, is highly effective, as mandated by President's law, as I said at the bottom. Now compare that to this. How convincing could you be if you put this in your report, or if you put these things with a little bit of explanation underneath, the way I explained them to you? I think that much more convincing. Everybody would believe this one. The other one, they say, yeah, okay, maybe you're right, but I don't really want to be bothered understanding all that. It doesn't matter whether it's an audit committee or senior manager or a minister. So with data science, we can actually get additional information, because here I'm dragging information from other places. Corruption losses are not part of that report. There were other things that we did, so that actually we can produce a totally different data visualization. Here's something that I have done with one of my teams. We looked at number of transactions. This was an audit of the warehouses. Sorry, of the warehouses in the local government authority here in Australia. So we looked, and what was happening, we were looking at every single transaction, and then we presented this as part of our report. It was closer to the beginning of the report, so that managers actually can see what's going on and then can make some sort of a conclusion. And we also provided some recommendation conclusions in this output. Now, Also, it's really easy with data science to assess the effectiveness of organizations' internal controls. We can use data science to analyze segregation of duties across the whole organization for every single person. One of the issues that we have quite often in organizations is the so-called, I call it permission creep. As people change jobs, they acquire new permissions to do stuff on systems or within processes. Doesn't need to be just digital, can be other things. But the permissions for their previous job are not removed. So if I worked in accounts payable and I have a set of permissions which I need, set of privileges within the organization which I need in order to do my job, when I change my job and I move into the business reporting team, so now I'm not dealing with accounts payable anymore, I'm mainly looking in general ledger and other data sources, the permissions from my previous job should have been removed. In most cases, they are not. In most cases, they stay. So if somebody changes 5 or 6 jobs in the same organization within the space of, let's say, 5 years, they will acquire so many different permissions. And now the segregation of duties will be basically not followed as a control. It won't be present. So I don't want the person who is approving a purchase order to be the person approving the invoice, or to be the person who is responsible for approving the delivery docket, and the person who is responsible for maintaining that asset, whatever it is, because the potential for fraud is huge, and segregation is designed to remove that. We can also very easily provide a three-way match. Because can you mute yourself? So with data science, we can easily do a three-way match. Three-way match is comparing purchase orders to invoices and to delivery dockets. Not easy to do in Excel, not easy to do any other way. We actually need to be able to link several data sets. It's not a trivial matter. In this case, we actually have to go and use some sort of a database, which takes us out into the realms of data science, because it's not very easy to link data sets otherwise. So three-way match is another one. Three-way match is an internal control, and this is what is designed to stop fraud in several ways, but we cannot check it. With data science, we can. Bank account flipping is another one. So it's possible that the person who is running a payment run for vendors is also maintaining the vendor master records. That shouldn't happen under any circumstances, but it may. Because if I can modify a vendor master record, what I will do before the payment run, potentially I can change one of the vendor bank accounts with my own bank account, do the payment run so that the payment for that vendor for that month goes not in their bank account, in my bank account, and then flip it back. That's why it's called flipping. So these are different permissions which exist on the accounts payable system or the financial system, let's say. And there's a number of people who have those permissions. But if we, again, link several data sets using some sort of a database mechanism, now we can actually look at checking bank account flipping all the way through for every single person. Is it possible? Can they do it? Of course, moving into more complex things in terms of data science, like let's say machine learning, we can actually start doing predictive analytics. We can actually start looking at predicting the risk of a project, whether the project is high risk or low risk at the beginning of the project, not at the end when we know that the project was high risk because it didn't deliver on time and on budget. And now we have to deal with these problems, but we can actually predict that at the beginning. That's done using machine learning and predictive analytics, which is now also part of data science. So these are some of the examples that data science can bring to your organization. We are close to half an hour. So just to summarize, these are the 7 benefits. If we start using data science simply initially, just simple data analytics and moving further up, it will increase the quality of audits, which would be very well received by management. It will make the auditors much more efficient. You can do your job much quicker. It will provide business improvement insights. For example, with predictive analytics, just I mentioned the projects, we can actually help the organization by saying, okay, this project is high risk. These are some of the reasons. We can do some more advanced productivity hypotheses using Benford's law as an example. Overall accuracy will be improved because we will be avoiding sampling. We'll be actually looking at the whole population of records or the whole population of activities. We can communicate our findings better, so our reports will have much more credibility and will be much easier to be accepted by the business or by the audit committee. And we can better assess the effectiveness of organizations' controls, because usually those controls go across several different departments, especially the pervasive controls, like, for example, segregation of duties. So you actually can do it across the whole organization. So we are running courses on that. There's one coming on the 16th of August. If you do a search on MBS Academy Eventbrite, like it shows here, you can find our courses and you can have a look if that's something that is for you. The courses are for 4 hours, and you will get an idea how to start with data science and what are the practical aspects of starting with it. So this is all from me. Thanks a lot for being here.